Good evening, everybody. So I'm Alex, I'm the coach of the team MRI. As I said, welcome to our project leader Nadine and to our customer Dr. Kai Megele. And these are our 9 developers who were very inspired by Kai's initiative to improve the healthcare of hand surgery patients.
Hi, our system guides a patient through his therapy exercises, ensuring his recovery. Hands are important for packing presents, for example.
I cut my bone, I cut my finger, I can't see my bone.
Micro.
Unfortunately, you cut your tendon, your flexor tendon, which is responsible for flexing your finger. I'll have to perform an operation. But don't be afraid. Now, I'll stitch you right up. Okay, you're all done and patched up. Please get up now.
Oh,
How do you feel?
I cannot move my finger anymore. Oh, what will happen to Christmas? Christmas is ruined.
Oh, don't worry, Santa. You can recover in time for Christmas. Remember Anna? You gave her a piano yet last year.
Anna with the piano. Yeah, I remember.
So she suffered from the exact same tendon injury as you. But she recovered very quickly with the help of our rehabilitation app. See for yourself.
This is Anna. Her dream is to become a professional pianist. Accidents can happen even while peeling an apple. This small but deep cut hurt her flexor tendon, a tendon responsible for flexing her finger. The operation was successful, but without correct rehab, her dream career will forever remain a dream.
You need to work closely with a hand therapist for your recovery.
Unfortunately, Anna lives far away from her nearest hand therapist.
Don't worry, we have just the right solution for your problem.
With Sharp, you can perform your rehabilitation exercises even without going to a therapist.
Thanks to the wearable with the app, the surgeon and the therapist, Anna is able to recover successfully.
Wow, what a smart app and a cool glove. I can't wait to try it out.
And you shall. Now, I will set up a treatment plan for you specifically designed for Santa. Now, I saved it. Now you can log in and navigate to your exercises.
And do the exercise with the wearable app work with. Helper Elf will help you to put it on. Combined with the app, it can track your joint angles during the exercise. The wearable is a true masterpiece, so innovative. And it was just adopted to fit Santa's hand, to save Christmas. So Santa, let's select an exercise and type the begin exercise button. Now, flex the fingers from green to green on a speedometer and repeat until no reps are left. See how the needle tracks the movement?
Yeah, dazzling.
So Santa injured himself and had to have surgery. Usually after that, he would do daily exercise with a therapist. Unfortunately, he lives in the North Pole, so that's logistically difficult. But with our app, he can do those exercises at home and only go once a week to the therapist. For that, our wearable tracks his movements, and the app gives him intuitive feedback correcting those movements. Let's see how we designed that system.
Okay, first we start with the user part. Obviously, we need a patient, a therapist, and a doctor. Since a therapist and a doctor are pretty similar in their behavior, we use an abstract class physician to group them. From the associations here, you can see that a patient has exactly 1 therapist and 1 doctor. Next, we have the treatment itself. We use the calendar and the treatment plan to store all the important information we need. For example, appointments and timing of exercises the patient has to perform. Speaking of exercises, for that we use the composite pattern to model these. Since an exercise set can have variable height and width. For example, it can consist of a simple movement, but it can also contain multiple complex exercise sets. That's why the composite pattern comes in here pretty handy. Also, we have an access control matrix, since only the physician can call, create, and modify of the treatment plan. The patient is only allowed to view his own treatment plan. And at last, we have our variable. The variable checks every single movement a patient has to perform. That's why we need at least one sensor. The actuators are optional. They allow us to actively move the hand of the patient. In other words, the patient performs a passive exercise. Now that we have our complete analysis object model, let's derive subsystems for our subsystem decomposition, starting with the user part. For that, we can use a data provider holding two different databases for physician and patient, since we store completely different data for both. We also have an exercise database, since we need to save its data remotely. It is connected to our subsystem, the treatment manager. Here, we use the treatment as our central controller, getting the data from the data provider, the plan, and the exercise. Since the user interface and the feedback is really important, we dedicated our own component for that. And at last again, we have our movement handler. The movement handler has the already introduced sensor and the actuator. We use a connector component to connect the treatment manager with the movement handler. Now, let's have a closer look on how the movement handler works.
The main functional requirement of our wearable is the fine measurement of the finger joint angles. With that in mind, we start thinking about different designs, as you can see on our mockups on the slides. There are two main approaches. On all the designs, we have the main board on the back of the hand, but the difference comes in the positioning of the sensors. There are two main approaches, having them over the knuckles or over the finger bones, the phalanx. Design A on C have the sensors over the knuckles, but after some research, that proved to be quite inaccurate. So we went with design D, having the sensors over on the phalanx. They are giving us a vector describing the position of the finger bones relative to gravity. The set sensors are called accelerometers, the blue ones on the slides, and our main board is the Arduino Bluetooth Nano, which is small and has Bluetooth integrated, our communication protocol of choice. So as I was saying, the sensors are giving us a vector describing the position of the phalanx. But what we actually need is the joint angle. So that means the angle between those finger bones. Luckily for us, we have maths. There is the equation, plug the vectors in, get the angle out. Now that we have the angle, we have to transfer the data to the app. For that purpose, we built a Swift Bluetooth framework. Since we do real-time computation, we have to synchronize. Our framework is noticing if packages are missing, and it also filters out bad ones. So, yesterday we established a Bluetooth connection, transferred the data to the app, and built intuitive UI, giving feedback and correcting the patient's movements. Tomorrow, we implement more complex exercises by the integration of more sensors. We also want to add the therapist functionality. Having said that, let's see how Santa's doing.
Dr. Elf, let me show you my exercise streak.
Let's see. Oh, I see you've been naughty on Sunday.
Yeah, Snow White distracted me. Ho, ho, ho.
Well, that can happen. But do flex your hand and show me your progress. Ah, that's some great progress, I see. You're basically healed, but do go easy on your fingers.
Yeah, sure.
Yeah.
Thank you, doctor.
You're welcome.
Now Christmas is saved. Merry Christmas. Ho, ho,
Wait,
ho.
hold on. Is there a knife in there?
Yeah, that's for you.
Is there a knife in there?
No.
Then I'll take it. Ouch!